The extraordinary properties of water. Learning objective. Explain how the properties of water that result from its polarity and hydrogen bonding affect its biological function. Properties of water. It's a polar molecule, cohesion, adhesion, high specific heat, density, universal solvent of life. Water. A water molecule, H2O, is made up of 3 atoms, 1 oxygen atom and 2 hydrogen. Water is polar. In each water molecule, the oxygen atom attracts more than its fair share of electrons. The oxygen end acts negative. The hydrogen end acts positive because the oxygen is pulling those electrons towards it. It causes the water to be polar. However, water is neutral, so it has the equal number of electrons and protons. It has a 0 net charge. It is only polar because the oxygen is pulling at the electrons stronger than the hydrogen is. The slightly negative regions of one molecule are attracted to the slightly positive regions of the nearby molecules, forming hydrogen bonds. So the hydrogen molecule, the hydrogen atom is going to be attracted to the oxygen because the oxygen is slightly negative, the hydrogen is slightly positive. Each water molecule can form hydrogen bonds with up to 4 neighbors. Here's a picture to help you remember. Cohesion is water loves itself. It stays together. Just think about co-workers. They work together. Adhesion is like water being attracted to something else. So you're adding something else. And surface tension is when the water molecules stick together with their hydrogen bonds and light things can walk on them, such as insects. This looks like a potato bug. Cohesion is the attraction between particles of the same substance. It's why water is attracted to itself. Results in surface tension, a measure of the strength of the water surface. Produces a surface film on water that allows insects to walk on the surface of water. Here's some cohesion. Helps insects walk across water. You can go and look up this Jesus lizard and you can see it walking on the water. Adhesion is the attraction between 2 different substances. Water will make hydrogen bonds with other surfaces such as glass, soil, plant tissue, and cotton. Capillary action, the water molecules will tow each other along when in a thin glass tube. Examples, transpiration, it's a process when plants and trees remove water from the soil, and paper towels soak up water. So here in the picture, we have the celery and the water molecules are coming up to the celery. You can see how the celery leaves are turning blue. Organisms depend on cohesion. Hydrogen bonds hold the substances together. It's a phenomenon called cohesion. Cohesion is responsible for the transport of water in plants. Cohesion among water molecules plays a key role in the transport of water against gravity in plants. So that's why water is going up the plants from the soil to the leaves. Adhesion is clinging of one substance to another. Examples, water adheres to the walls of blood vessels. Adhesion also causes water to form spheres and hold on to plant leaves attached to silken spider webs. Cohesion is the water molecules sticking together here. Here's the water surface, and then we have the adhesion, and it's attracting to the side of the glass. This is in a graduated cylinder when you're reading the meniscus. Here's just another picture. Adhesion, it's grabbing onto something else. Cohesion, working together. And they're polar or charged objects. If it's non-polar, it will not be attracted to it, like oil and water. High specific heat is the amount of heat needed to raise or lower 1 gram of a substance by 1 degree Celsius. Water resists temperature change, both for heating and cooling. Water can absorb or release large amounts of heat energy with little change in actual temperature. That is why it is used in car radiators. Specific heat is the amount of heat that must be absorbed or lost for 1 gram of a substance to change its temperature by 1 degree Celsius. 3/4 of the Earth is covered by water. The water serves as a large heat sink responsible for prevention of temperature fluctuations that are outside the range for suitable life. Coastal areas have a mild climate because of this, and it creates a stable marine environment. Evaporative cooling. The cooling of a surface occurs when liquid evaporates. This is responsible for moderating Earth's climate, for stabilizing temperatures in aquatic ecosystems, preventing organisms from overheating. So when you sweat, you are releasing heat from your body. Water is less dense as a solid. So ice is less dense as a solid than as a liquid. That's why ice floats. Liquid water has hydrogen bonds that are constantly being broken and reformed. Frozen water forms a crystal-like lattice whereby molecules are set at fixed distances. Ocean water is more dense than fresh water. Density of water. So it's most dense at 4 degrees Celsius. It contracts until about 4 degrees Celsius. It expands from 4 degrees to 0 degrees, so the colder it gets, the more it's going to expand. Seawater is more dense than fresh water. The density of water prevents water from freezing from the bottom up. It causes ice to form on the surface first. The freezing of the water releases heat to the water below, creating an insulation. That's why some organisms can live in the frozen water. There's still fish living in frozen lakes, and it can make transitions between seasons less abrupt. Water is a universal solvent. It can dissolve almost all substances, the polar molecules. It cannot dissolve nonpolar molecules like oil, butter, petrol, gas. And it does this because it's a polar molecule. Remember, polar means that the hydrogens are slightly positive and the oxygen is slightly negative because it is pulling the electrons closer to it. A solution is a uniform mixture of 2 or more substances. They have a solute, which is the dissolved substance. It's in the lesser amount. So if we were doing this salt water here, the solute would be the salt because it's in the lesser amount. And the solvent would be the water. It's the substance that is dissolving, and it's in the greater amount. For salt ions, when you dissolve the salt in the water, you can see that the sodium has a positive charge, so it's going to be attracted to the oxygen, which has a slightly negative charge. And the chlorine has a negative charge, so it's going to be attracted to the hydrogen because that one has a slightly positive charge. What you're going to do is you're going to click on the water droplet and go and complete the true or false quiz on water properties quiz. Once you're done, take a screenshot of your score and paste it in the box below.